Hi guys, how's everybody doing this week? I want to make a couple of videos this week for you. The first one I'm going to make today is a standard access control list. We have several types of access control lists that we typically use. We have standard access control list, extended access control list, named access control list. I'm wanting to start with standard. We'll go ahead and open up Packet Tracer. If you look at Packet Tracer here, I've built a configuration for you to look at these access control lists with. You see I have a PC over here on the 172.16.00 network, and this PC is 172.16.02. I have a switch. I have a router that's labeled as US. If you look in this guy, it's typical stuff like you would see from me. Please for the passwords, enable to get in there. We do a show run, and you see that everything's encrypted. We have the MDA5 encryption on the enable password, Cisco Type 7 on everything else. The Ethernet is what you would expect it to be, 172.16.01 to support the 172.16 network. The clock rate, or the DCE end of the serial link, is on serial 00. We're using 10.0.0.1 network. We set up RIP and we advertise the directly connected networks, 10 and 172.16. Now, one thing that I am getting some questions about that I want to point out to you is when I'm doing a lot of these videos, if I'm not subnetting, then I'm just going with the private address space, the 10, the 172.16, the 192.168. If I am using something that's larger and I have the subnet, I will let you know that I'm subnetting, and you will see a mask that's larger than the default. In this case, if you look back up here, the masks are all the default masks, so there's no subnetting going on. I have a Class B network, 172.16, and a 255.255.00 mask. I have a Class A private address, 10.0.0.0, with 255.0.0.0. So there is no subnetting going on in this. If you come over here and look at this guy, you got a very similar thing going on here. I can't type please, apparently. If you look in this router, you'll see same thing, same type networks used, RIP, advertising everything. If I do a show IP route, you see that these guys know everything. This is using the 192.168.3 network, which is Class C private network. I'm using 255.255.255.0 as my subnet mask, so there's no subnetting going on. Just to show you that everything works, if I come here on this guy and do an IP config, you can see that I am in fact 172.16.02. The furthest that I could possibly ping on this network would be to ping 192.168.3.2. And as you can see, I do have connectivity all the way to the far reaches of the network. So this gets into the idea now of what is an access control list. An access control list, you can look at it as a filter list. You can look at it as a firewall of sorts. It's a way to prevent traffic on a network. Now, I'm going to throw a couple definitions up there at you, and we'll look at them. The first one we'll do is we're talking about access control list. Okay, one of the first rules you need to know is one list per protocol, per direction, per port. And what that means is if I have an access list and it's specifying TCP/IP as the protocol, I can only have one TCP/IP or one UDP protocol list on a given port for a given direction. Now, when we get down and we talk about standard access control list, okay, we have a list of things that we can say about them. And one of the things that we can say is that the number for the list is between 0 and 99. Okay, let me show you where we would find that information. If I come in here and I'm on this router right here and I say config T and I look at my options, you see access list is an option. So I type in access list and do a question mark. And it says, okay, what access list do you want to have? Well, since I'm writing a standard list, I'll pick a number between 0 and 99, and we'll say 15. Okay. Oh, hang on, let me go back. I made a boo-boo with my typing. I thought it should have shown me a list of ranges. Okay, there you go. 1 through 99 is IP standard, so we're going to go with 15. And then you see the first thing it says is, do you want to deny traffic or do you want to permit traffic? Well, if we come over here and look at this, right, this guy can ping all the way over to here. So let's say that we want to deny him, and this should be 1 to 99. Okay, so what you get to do is you get to specify the source of traffic. Okay, destination affected is chosen by where you place the list. Okay, well, let's take a look at this guy. Since I have this list right here, and I'm saying access list 15, I want to deny. And the traffic I want to deny is I want to deny traffic from 172.16.00 network. And look here. It doesn't say subnet mask. When I did the question mark, it says wildcard bits. Now, I asked you guys in class to tell me the difference between a subnet mask and a wildcard mask, and I got some really great answers. But let me tell you the way I look at it. A subnet mask tells you which portions of an address correspond to network bits, which portions correspond to host. All the ones set say the corresponding information is network. All the zeros say the corresponding bits indicate host. With a wildcard mask, basically what happens is a 0 in a wildcard mask says these bits have to match exactly. So if I say 0, then that means everything in the first octet, which is 172, has to match exactly. So everything that starts off with a 172. If I say another 0, then the 16 has to match exactly. So this is going to catch everything that's 172 and everything that's 16. Now, the ones, on the other hand, mean I don't care. So if I say 00, 255, 255, I'm saying that I want to catch everything 172.16.00 network. Everything. Okay? Now, the other thing that's interesting about an ACL is, with the exception of named ACLs, I can't edit them once I've put them in there. So if I make a mistake, all I can do is go back and remove the list and recreate it. So in this case, I have an access list that says access list 15, deny 172.16.00.00.255.255. In other words, it's going to deny everything from that network. The one thing you have to remember is with a standard access list, it ends with an implicit deny any, or deny everything. So just to make sure that I'm not closing down that port, I have to go in and say permit any. So in other words, anything that I didn't specifically deny gets accepted. Now, if you look over here, it says standard access list, number for the list is between 1 and 99, specify the source, destination affected is chosen by where you place the list. Bind the list to an interface and specify direction. Now remember, you do have to follow this golden rule of access list up here. And that is one access list per protocol, per direction, per port. So let's come back here and look. If I look at this guy right here, if you notice, I can still ping across to the other side. I also can still ping my gateway. Well, what if I come in here and I say, let's go to interface S0/0, IP access group 15 out. In other words, I want to take this access list and I want to look at it on this port right here, S00, when traffic is going out. So in other words, any traffic coming from 172.16 that goes in this router will get denied going out past this port S00. If you want to see how this would look, some of your show commands, you can do show access list, and you see I have access list 15, and that gives you the information. I can also do show IP interface. And if you notice when you look at, where's my serial interface? My serial interface, you notice that I have an access group outgoing set right here in this line. So let's go back over here and see what happens. I've created the list and I've applied it to an interface. I can still get to my gateway. Look at what happens when I attempt to get all the way over there. Why is it saying destination host unreachable from 172.16.1? Because that's as far as I could get. When I got here and wanted to go beyond, it said no way. Well, what if I come in here in this router and I go to CompT, interface S00, and say no IP access group. Wow. Oh, sorry, my bad. Okay, it's going to make me do the whole thing. So you do get to see an example of removing it. Well, now that I've removed it, what happens if I come back over here? You notice I can ping again. I got the access list out of the way. You notice when I grouped it on S00 going outbound, I could not get to here, but I could get to my gateway. What if I come over here now and say interface F00 IP access group 15 in? Well, what's happening now? I'm looking at that filter specifying any user or source on this network as it goes in. So will I be able to ping that destination? No. But because of where I changed the source to, I can't even ping my default gateway. So what lessons should we take from this example? One access list per protocol, per direction, per port. A standard access list is going to have numbers between 1 and 99. If you go out there and actually look it up, you'll find out there's some numbers up in the thousands that can be used for standard also. But no more than we're using, 1 through 99 will be fine. You have to specify the source of traffic. That's all the access list lets you do. You do not use subnet mask in a wildcard and an access list. You use wildcard bits. They tend to be the opposite of what the subnet mask would be as a general rule. The zeros mean the corresponding number has to match exactly, 1 meaning it doesn't matter. The destination affected is chosen by where you place the list. If you notice when we placed it on S0 outbound, we kept it from getting to the remote computer, but it could still get to its gateway. when we moved it back to where it was on the inbound of the router on F00, it couldn't get to either. So the binding had a lot to do with placing that. The other thing I would point out to you is some people say, well, you keep saying inbound, outbound, inbound, outbound. What do you actually mean? Well, what I'm actually referring to is if I were pinging from here to here, imagine tracing a line that started here and went all the way over to there. As we go from here to here, it's going to go in this switch and then out this interface. In the F0, out the S0. In this S0, out this this F0. In this switch port, out this switch port, out to here, and then it's going to reverse going back. So that's what I mean by inbound, outbound, and that will actually give you the path going from one way to another. You have to be careful because remember, an access list ends, standard ACLs end with a default deny any. So if you remember, that's why I had to go back in there and put the permit any, because otherwise I would have effectively shut this port down for traffic from anybody. Have fun playing with this, guys. This is my presentation on standard ACLs.